Hello everyone, so here we're going to learn how to measure mass and volume. Two important things to know when we're in lab. You'll need your notes, which is your pen and paper, and you also need your lab notebook as well. We're going to learn how to measure mass, then volume. So when we measure mass, we're going to use our electronic balance. This is a Scout OHouse Scout Pro, and we're going to use these for any time we want to measure out solids or liquids inside a container. So before we even measure the mass, we have to actually calibrate the balance. Calibrating means that if you're going to put on a certain mass onto the pan, that's what the mass is actually going to be. So you can actually read through these directions. This is what I want you to put down in your lab notebook. Get this down and make sure you write down each step properly. I'm going to start with the balance off, and then plugged in but off, and then press and hold the on and zero button until you see a menu button on the menu on the display. It'll take your hand off that button, and then it should say CAL, which is for calibrate. Then you press that button again. Just press it, don't hold it. Just press it once, and it should have like this C that flashes. That means it wants you to calibrate it. Put the mass on, which is a 200-gram mass. It's a little cylinder that I'll show you, and we usually have them in the lab for you guys. And then press that on zero button again, and then it'll flash a C and then done. So if that works, great. Now your balance is calibrated. So that's pretty much what you do to measure out the mass. Don't forget you also need weighing paper or a weighing boat. Use paper to be a little bit more conservative. If you know you need a lot, use the weighing boat. But don't put anything directly on the pan because you never know how it's going to react with the pan itself. And always keep your balances clean as well. Alright, so measuring out volume. We have a whole bunch of different equipment here used to measure out the volume. Typically we always use a graduated cylinder, but you can also use a syringe. Eventually in acid to base or titrations we'll be using a burette. We can use pipettes, or if we're going to make a solution we use volumetric flasks. So actually one quick note about the burette, and make sure you write this down in your lab notebook as well. The burette is read upside down, or backwards essentially. So if you notice on the graduated cylinder, the bottom would be 0, the top is 100. It's the opposite on the burette. The top is 0, the bottom in this case is 50. So when you're reading this, make sure that if like the level is right here, between the 2 and the 3, you're reading it as 2 point something, not 3 point something. Alright, so again, make sure that's read accurately for that burette. And I might try to trick you, so make sure you check in here. Alright, so if you have a solid, there's two ways to measure the volume of a solid. One is the geometric measurement, meaning if it's a perfect cube, use the length times the width times the height. Always measure in metric units, so centimeters or millimeters. If you have something that is not a uniform shape, for example, this little plastic dinosaur, we need to know what its volume is. We can use something called water displacement. The first thing you do is find a graduated cylinder that it will be big enough to hold this little dinosaur, but you'll take the measurement first of the volume of just the water, then you'll put the dinosaur in, he'll go down towards the bottom, and then you measure what it is after. That difference between here and here, the before and after, that difference is the is the volume of the dinosaur itself, or in this case the dinosaur. Alright, so measuring out the volume of liquids, going back to this. We have so many different graduated cylinders, we need to know how to use each one of them. So these go down from 50 milliliters to all the way up to 1 liter. Typically ours go from about 10 milliliters to 100 is usually our cutoff point. So we want to make sure you determine what the increments are between these. So for example, in this graduated cylinder, each of the major lines are by 10, so there's 10, 20, 30, and 40, and then you have a smaller line there, so this would be your 15. Then even smaller lines, so each of those teeny tiny little lines are going to be one more unit. So if I had something around here, you take the like 16 point whatever it ends up being. In this case, what this person is reading is 22.0 milliliters. Make sure eye level. Eye level is different for many of us. We have to bend over a little bit more for some than others. This is kind of the good thing about being short. Take the reading and then estimate it to one more place. So let me just eliminate some stuff over here. Oopsies. Let's get rid of all that. Alright, so we see that the water level, the bottom of the meniscus, goes to 22. However, we want to put one more place after it as our estimate. And let's show you how to do that here, a little bit more zoomed in. So let's take a look at A. First, let's make sure that we're measuring or reading this correctly. It goes from 50, then 60, so it's measuring up. Of course, if it was a burette, it would be backwards. So we go from 50 to 60, then we have this line right here, and then four smaller lines. So you know this one's going to be 55. Each of these lines are going to be one more. So reading this meniscus right here is at 56. We're going to use one more place though. So since, and I'm going to erase all that, since the meniscus is on the line itself for 56, we can say it's 56.0. Make sure that decimal point is pretty obvious. Forget that. There we go. That's obvious. Alright, so that's 56.0. Let's go to B. We have a measurement here, so we go from 3 to 4, so this would be 3.5. That would make this 4.5. So let's read our meniscus. Each of these small individual lines are a tenth of a measurement. So this is 4.1, 4.2, 4.3, and 4.4. So we're at 4.3 plus an estimate. So we have 4.3, and if we clear this up a bit, we can see it's about halfway between that 0.3 and 0.4. So we can estimate it to be 4.34 or 4.35. These two numbers are exact numbers. This is your estimate. So we might all be reading this last number a little differently, and that's okay. That's why we all take that estimate, so we know that that last number might be a little off, but that's fine. These first numbers, however, should all be the same. Go ahead and try C on your own. And we should see that this should be 25. So each of these are small little increments. So this is like 21, 22, 23, 24, and then 25. So we have 23. We should all have gotten 23. And then for each of us, that last little number might have been a little different. So I see about 23 point, so maybe about 6, depending on where the meniscus is. So again, it's all different for each of us. One thing that we're missing here are units. Now, if we had the whole graduated cylinder, we would see that these are all in milliliters. But let's go ahead and make sure that we write out milliliters for each of them. In fact, I'm going to erase that 43.4, and rewrite it, because, actually it's 4.34, yeah, milliliters. Because I want to see which one of these measurements is the most accurate. To figure out which one's the most accurate, it goes to the most amount of decimal places. So we should have B here. That ends up being a little bit more precise, because it goes to the furthest decimal place or out. Go ahead and try these on your own. Alright, if you're not done yet, go ahead and pause me and then come back, but let's go and work on these. So we have 15 to 20, it's going up, it's not a burette, so this should be 16, 17, 18, 19, and then up to 20. So we have 16 point something. So 16, that's what we all should have had. And then whatever that last little number is our estimate, so I would say about 16.8 milliliters. Right, for E, these all go up by one little unit, so it's 76 would be this line right there. And it's pretty much on the line, so I'm going to call it 76.0. If you see something a little different, that's fine, as long as those first two numbers are the same. And if I goofed up on these kiddos, let me know tomorrow in class. Alright, for F, let's see, we have each of these go by 2s, so this would be 5.2, that would be 5.4, so in between would be about 5.3. Alright, and that would be our estimate because we can't really quite go any further. Let's see, let's keep going, that's milliliters, let's not forget. Go ahead and try these and then pause me if you're not done yet. But let's go through these. So I have, these go by 2s, so that would be 32, whoopsies. I see 32 right there, and it's right on the line, so I'm going to call it a 32.0 milliliters. For H, these also go by 2s, so 3.2, 3.4, 3.6. So I would say about, it's not quite halfway, maybe 3 point, say 3.5 is good. All right. And for I, let's go to this one. So 45 would be right there. That's 46, that's 47. And that's right on the line, so I would say 47.0. And of course, these are all in milliliters. All right. So, hopefully you guys did well on those. When we're measuring mass, calibrate it first and then take the reading directly from the electronic balance. When we're measuring volume, choose the appropriate tool and the size of the equipment, and measure and take one more digit than you need as your estimate. Have a great day, guys.